Fantastic. Welcome to our next session, From Code to Production, Implementing CI/CD in SaaS Viya. So I'm Dan Ciccano. I'm in Global Technology Product Marketing, and I want to introduce Don and Laurent from PW Consulting. And gentlemen, if you could just introduce yourselves and tell everybody what you do and the scope of your work with SaaS, that'd be great. All yours.
Yeah, thank you. Yes. So I'm Laurent de Waalik. I'm working with SaaS since 2003. So that's over 20 years now. I'm a consultant with PW Consulting. Mostly I've done a lot of data management things, ETL, data integration. And the last years I'm focusing more on architecture and implementing SaaS solutions with customers.
Yeah. Hey guys, I'm Daan Bloem. I work as a SaaS consultant for PW Consulting since 2017. I've primarily worked with SaaS Viya. My focus areas are health and life sciences. I'm an agile enthusiast, so basically now I combine the roles of developer and Scrum Master.
So PW Consulting is a consulting firm in the Netherlands. We've been founded in 1988, so we're 37 years old. Our main focus has always been SaaS, and the last few years we've also diversified a bit with some new technologies, but all business analytics, AI, and yes.
Okay.
So now this presentation will be about our journey from when we started using the latest Viya version. For me, this was the first time, and we started just coding, but we discovered that we needed better processes to create a reliable product. And we'll bring you along in our journey, how we implemented a CI/CD pipeline. And Daan was the first one working on the project. I joined later, so Daan will give you first the first steps we did by implementing Git.
Yeah, thank you, Laurent. So CI/CD, it stands for Continuous Integration and Continuous Deployment. But I would like to argue that at least from a way of work perspective, the CI could also stand for Continuous Improvement, because that was really the case for us. During this journey, we transformed our development process from quick and dirty prototyping towards a really robust and well-established production process by adopting an agile approach. The first step in our journey was really to implement Git, and this was the foundation for all other improvements we made later on. So at the start of our project, we worked with 3 developers on the same piece of code that was stored locally on our SaaS Viya installation. Through some kind of continuous pair programming, we tried to make extra features on the software. But well, as you can imagine, problems arose quite soon in terms of versioning. Conflicting changes that are made between different developers, bugs slipped in. It was quite difficult for us to keep track of the latest working version of the code. So therefore, a flexible and easy way of versioning became very desirable. Well, Git was quite promising for a solution for us to overcome these problems. So the first thing we actually did was to store the latest version of our code as a central repository in Bitbucket. I will show you how this works conceptually. Let me try the pointer. Okay, no pointer. So okay, in the bottom left, you can see that we have a central repository where we store the latest version of our code. This is also the main branch, we call this. We then fork branches of this latest version of the code, and we check this out in SaaS Viya. So the top layer is our SaaS Viya layer. We check these branches out in Viya. We make developments, changes, and then we commit and push those back into Bitbucket, where we can merge our feature branch back into the main branch. So how this works in real life, not sure if you can see it real good, but on the top left you see a small folder with my name, that's Daan. So that's my local repository on the file system of SASVIA. And this is a clone of the central repository we stored in Bitbucket. So if I want to get the latest version of this central repository into my own repository in VIA, I have to do a git pull. So this is a function that you can perform in the Git interface. For this presentation, I've created a branch. It's called SAS Innovate at Customers. It's totally fictional, by the way. And as you can see, I've added SAS programs. In the middle, you can see that I've staged the changes I've made. And on the right, you can see all the code that was added to the program. So for this example, I only added code, so it's only green. But for instance, if you delete code, it becomes red. And if you change lines of code, it gets different colors. It's really trackable. So what I want to point out here is that this way of working really enables you to make changes in your branch that do not interfere at all with the main branch. And you can also keep track of your changes in a visible way in the interface. What I also would really like to highlight here is that we leveraged Git to really improve the quality of our code by functional testing. So as you can see on the left, this is a screenshot of the file system of SASVIA. Our personal repositories, that of my colleague Laurent, they are physical paths on the file system. So this enables you to parameterize the paths and then execute the code dynamically. We've built a SAS job with HTML code, where I've added the paths as an option to select, and this HTML code resulted in the small interface you see on the top right. So there you can select the Git repository you want to execute, and then just execute the code. So for all features we've built for our product, we created these interfaces. And then what happens is that SAS, you can see it below on the right, executes the code dynamically. So the code base, it's a macro variable that's filled with either my repository or Laurent's repository. What is really nice about this is that you can functionally test the changes you've made on the product before you push it and commit it back into the main repository. This resulted in way less bugs and errors. And also, at one point, we made it part of our definition of done that you, before you create a merge request, you add the test report where you prove that your code works from your repository, and also a log file without errors and warnings. So to wrap up, now we've implemented Git in our development process. So we were able to check out branches in our own personal repository in VIA, create changes and push them back into the main repository. But the challenge we now faced was how to get this latest version of the code in Bitbucket back into our production layer in SASVIA. You can do this manually by executing SAS code with Git functions. But this manual way was really prone to errors because still it was not clear sometimes which version was the latest version. And also we did not have any tests and checks in it yet. So the next challenge we faced that we really needed to automate this part of the development process in order to keep quicker deployments. And this is where the pipelines come in. So my colleague Laurent will elaborate on this. Thank you.
Okay, so now we have version control for our code in place, but the latest version was only available in Bitbucket, and we still wanted to run in our test environment with the latest, where we have regression tests every night scheduled. So how can we assure that once we merge a feature branch into the main branch, that it's also updated in our test environment? First, as Daan showed you, we did it manually, but this was prone to errors, forgetting, doing the wrong branch. So this is where the pipelines come into play. What is a CI/CD pipeline? Well, CI/CD, we have continuous integration. That's what we do with Git, so continuously updating our code into the main branch. And then the continuous deployment is deploying that code automatically to the, in this case, the test or production environments. So if we go to our process, so this is the main branch. We created a feature, did our development work in VIA, pushed it back to Bitbucket, and then here we do the pull request to have it back into the main branch. And now we have an automated process when we push it to the main branch that will run in the background and upload the latest version of the code to the test environment. For this, we're using pipelines, and for for our pipelines, what happens? We created a Docker container, and the Docker container, we used Alpine Linux, this is a small version of Linux, and we used 3 tools that we can then rerun scripts that use 3 tools. The first one we have is the SAS command line interface. We can interact with the SAS VIA server. And that was the preferred method to do the interaction with the SAS server. We also used curl because there were a few limitations in the command line interface. And the command line interface, in the background, it uses the REST APIs from the SAS VIA server. So we can just write our own code using curl, which is a command line web browser to post, to do HTTP post request. And JQ, which is a JSON query. We have several JSON files, templates that we can modify during the deployment to inject updates that are specific for our test environment. So how does this work? We work with Bitbucket. If you use a different Git tool like GitLab or GitHub, it's similar, might be different, details might be different, but the essence will be the same. We do a merge, so Bitbucket knows there's a merge. What happens? It will pull the image that we've created, the Docker image, from a Docker repository. So here I have my Docker repository and the image I want. I have the username and password. And here I have in the, this is the YAML file with configuration, and it says when I will update to master, then it needs to run the deploy production step, and here I have the deploy production step. So once it pulls the image from the Docker container, then it will run a script. And that script is just a shell script where you can do anything you want, as long as the tools you want to use are available in that container. So first one, what we wanted to do was update the SAS code in our test environment. So for that, we're using the command line interface. What we do is we always download the latest versions of the plugins that we're going to use. This is choice. You could also put create a container with the plugins in the container, but then every time that you need to update the plugins because you update SAS VIA, you also need to update the container. So that's a choice you can make. Then you need to log on to the SAS server. That's a function of the CLI. And what we did is we created a SAS code that we used the batch plugin to submit, and that was that's a SAS program that just does a git pull and retrieves all the code from the Bitbucket repository and puts it in what we call latest build. That's our test environment, and then it's updated. And this runs every time that we do a merge. It's nice. Now our code is always up to date in our test environment. But now we wanted more. Like, we also want to update our schedules. We also have certain SAS content objects that we also want to update. So this is when we started to expand the pipeline. In this case, we have some SAS. We want to create some SAS content objects. So in this case, we have a bit of SAS code. We just write SAS code, and then what we're going to do is we are going to create JSON files where we insert the right information so that we can create that content using, in this case, we're using the REST APIs. This is because we wanted to put them in a specific folder in the SAS content server, and the CLI does, maybe it does now, but at that point you couldn't put it in a specific folder. You can create SAS content, but not in a specific folder, so then you can only find it with a search. So we had to rely on the REST APIs. And then we needed JQ to modify our JSON files. So I hope it's readable. We have a template, a JSON template. This is for all our job definitions that we want to create. It's always the same. It's the basic. This is what SAS expects when you're using the REST API to create a job definition. Now, this is the SAS code that we want to create a job definition for. And then we also have, in this case, I created a parameter. So we have for the copy class, if we find a param copy class.json, that means that we have parameter that we want to add to the job definition, and our process just picks it up. And what it does is, here you see the JQ file. So first, what it does is this SAS code, it needs to convert it into a string that JSON accepts. So we read the SAS file and create a JSON file, and then that creates to this string. So it's a single line, and the new lines are changed into a /n. What next we do is we insert that, so here we created the code.json, we insert that behind the code element in the JSON. So we first created a text file which only contained the converted code string, and then we insert it in our template. Same for the parameters, we insert it in the template, and then we have this is then the completed JSON where we added the code-specific parameters, and we have always default parameters so that we always run on the right execution context. And this is the JSON that SAS requires for the REST API, and then with curl we can post it to the SAS server, and in the end a new job definition is created with the SAS code. And this runs every time that we do a merge, so it's nice also. We see all the pipelines that have run. If it fails, it's immediately clear that something went wrong and that the merge has failed, the build has failed, so you need to check it out. Was it something in the code, in your templates? You can fix it and then rerun it again, and then it's successful. This was nice, our first step. We started. After that, we also added some scheduling. So now every time that we do a build, we also, not only do we create a job definition, but we also create scheduled objects, and we can schedule them, and it will automate so that we have our nightly run automatically runs with all the latest version of the code, and the next morning we can check if everything still works as expected. This is the deployment part. But once you start working with it, you see a lot of opportunities to improve the process. Because automation, in the end, the more you automate, the better the quality becomes, because you have less manual work, less errors. So first, we only had a pipeline here, but now we also added a second pipeline during our continuous integration phase. Because when we do the merge from our SAS Studio back to Bitbucket, we can also run something, check if everything that we pushed the feature if everything is like we wanted it. And if the pipeline fails, then we reject the branch, and we're not allowed to merge it to our test environment. So that's a way to improve the quality. And what are we currently doing? We have two quality improvements. One is we do some code validation. Is the code according to our standards? And the second, we implemented unit test automations. Both run. If the pipeline fails, you can't merge it to the main branch. It will never make it to production. And you need first to fix it. So, our code validation. This is a simple linting process, which is common in a lot of programming language. We use the SAS.js, it's an extension. We just defined a few standards that we want our code to comply to. So we always want a header, which in our case we have chosen, it's a DoxyGen standard header that describes what the file does. We agreed that all file names must always be lowercase. We're on Linux, so case sensitive. So everything lowercase, then can never be issues with file names. We have a maximum file length of 255 characters to avoid any issues with the SAS. We all know the SAS issues with the quoting. So this we check on it, so it's not during our run that we run it. Checks if there are no hard-coded passwords. Always important that you want to avoid hard-coded passwords. And also some, just nice to have no nested macros because you can't just maintain all the code. And this is just a script, runs, and if the pipeline fails, it gives you exactly on which file, on which line it detected an error that's returned in the pipeline, and then you can just fix it directly in the feature branch and then merge it again, and hopefully it will run. And our second improvement was we started doing automated unit tests. So for each program that we develop, we also develop a unit test, and that unit test must pass. So, so for every SAS program, in the example you had, what was it, copy class. So we also add a test copy class, and in the test file, we first create input that's required. We create a validation, so and then we validate if the input and output, if the result is the expected output, and the SAS program is added as an include statement. So it runs, and your test should be successful, but if in the next iteration of the development a user changes the code without changing the test and it fails, then did he change something in the code without wasn't supposed to be, or was the test not updated? But we need to fix it. And also, so as all the tests we write run every time. So on each merge, we have a directory with all the test files, and we just run them one by one by one by one, and they should all pass. And you can write, multiple test cases, and it really improved the quality of our software, and much less issues once we go to the main branch. And then when we run it in the main branch, now the product has become a lot more stable. I think we're a bit faster than I expected, but we're through with the presentation, so I'm open for questions.
Fantastic. That gives us tons of time. But before we get into questions, please a quick round of applause for Lauren and Dan. Thank you. So if you have a question or a comment, just raise your hand. I'll bring the microphone over to you.
Thanks for the presentation. I'm curious on the test cases. Do you have an example you could show of an example test case execution or anything like that?
No, I don't have any on this. But what we do is we create a data. So we have an input data set, and then we create an output data set, and we compare. So we run the code, and we compare those data sets if it's still the expected data set, and we simply write. Yeah, we have an abort statement if it's not the expected.
So are you using something like proc compare or something to
Yes.
compare the data sets?
Yeah.
Okay, thank you.
I heard you talk about the SAS jobs and that you can also deploy them from one environment to the other.
Yes.
Are you also saving them, like the job definitions, in your Git?
Yes. So
You have version control.
so not the generated job definitions, but the template and the different elements to build the job definition are all in Git. So if we go back to, let me. This is all stored. So this is all stored in Git, and then we generate this at runtime, but we can always rebuild it. So everything is stored in Git. So the template, and also the additions to the template, that's all stored in Git. We still have all versioning on those. So if the REST API spec will change, then we can change the template, and it should work for all jobs.
Maybe a small follow-up question. When you run the pipeline, does it take all the jobs from a certain folder or something and like?
Yes. So it
copy all
looks
of
in
them?
folders, and if there is it matches by name. So in this case we have the copy class, we have a PowerArm copy class, and for all the jobs that are in the directory, it just creates a job definition. And we have a certain directory where we put the jobs in that we want to create a job definition for. We have another directory where we have just code that we don't want to create a job definition for. And same for the scheduling. For the scheduling, we have a directory where there is schedule copy class with the JSON that will be merged. So, and even we haven't it yet, but the idea is also to have test and production. So you can have a test schedule and a production schedule. So that's all maintained and versioned. And because of the speed, you can also just really deploy fast, even to production if you want to.
Awesome, very clear.
Going back to the unit testing. So if we're doing something like leveraging proc compare, I'm assuming that is for something where you're like, I'm expecting it to be the same. But
Yes.
let's say like your code change, you're not expecting it to be the same. In that case, would you write something custom every time to then add to your unit testing, or what would you do in that approach?
Yeah, so the unit testing is quite flexible. We really write, depending on our code, our test comparison. So it can be a compare. Sometimes we have macros where we just have an output, and we have macro variables where we expect a certain output. So it's
sorry, but basically what we do there when we write the macro, we already like define some scenarios. So let's say if scenario X happens, then set error level on a certain value. And then after executing all these tests, we build a macro around it, and then we say, okay, expected error level is, for instance, 7 because of this scenario. And then when this error levels match, then it passes the unit test on this way.
Okay, that makes sense. And then, so I'm very pro doing unit testing, but I feel like it's hard sometimes to convince an analyst, like, oh, it's definitely worth the time. So what would you say to someone who's like, what's the just pure benefits and the justification for doing it?
Our technical depth decreased big time. So yeah, it made it way more robust, way more reliable, the code every time we made a new feature update and added new unit tests to our macros.
Okay, thank you.
Yeah, and also, so for the unit test, we just have a rule in the that we in our review phase, if there's no test cases defined and no unit test, then it's not accepted. So the developer, yeah, it won't be merged. So it's also just agreement between developers that you want to improve the quality.
We still use SAS 9 and we use packages. Does this process support importing or exporting packages to the server?
You could probably tweak it also for SAS 9, but yeah, you don't have the benefits from when you're just having code. Like now I can see if I change the code, which lines, yeah, if it's a package, it's a binary. Of course, you can automate. For the pipeline part, you could automate things also for SAS 9 with the batch tools. But it will be more difficult than in VIA because of the REST APIs and the CLI. Yeah.
Got it. Couple of follow-up questions. Do you do labeling when you promote code?
Sorry, do we?
Labeling in Git?
No.
Apply labels, or you just pick the latest version?
For the build, we always pick the latest version for build for our test environment, and we create a feature branch per user story. So our feature branches are pretty small.
All right. Thank you.
Anyone else? Going once, going twice. All right, just a final round of applause for our presenters, please.
Thank you.
Thank you very much.